Hello everyone, this is the third part of the lesson real numbers, which is the 10th chapter of class 9 mathematics. Today we are going to do the third problem of the first exercise. The part of the number line between the points denoted by the numbers 1 by 3 and 1 by 2 is divided into 4 equal parts. Find the numbers denoting the ends of each such a part. Okay. Suppose this is our number line and we take the distance between the points 1 by 3 and 1 by 2. Okay. 1 by 3 and 1 by 2, and this distance is divided into 4 equal parts. Okay. 4 equal parts means, yes, by using 3 points we can divide it into 4 equal parts. Okay. So first point, second point and third point. Then we get 4 equal parts in between these 2 points. Okay. 4 equal parts. And these are the endpoints of each such a division. And we need to find out what is the what are the points A, B and C. Okay. See, the distance between 1 by 3 and B. Okay. Distance between 1 by 3 and B and 1 by 2 are equal. Right. 1 by 3 and B and 1 by 2 are equal. Okay. Because we divide the entire space into 4 equal parts, and 1 by 3 to B and 1 by 2 to B are 2 equal divisions of 2 equal divisions, right? So this B is actually the midpoint of this 1 by 3 and 1 by 2. Okay, 1 by 3 il ninnum 1 by 2 il ninnum ഒരേ അകലത്തിലുള്ള point means 1 by 3 and midpoint of 1 by 3 and 1 by 2 is this P. Okay, so the point B is the midpoint of 1 by 3 and 1 by 2. And how do we find the midpoint of 1 by 3 and 1 by 2? For that, yes, 1 by 3 plus 1 by 2. Take its half. Okay. Then what is 1 by 3 plus 1 by 2? From the second chapter we know what is 1 by 3 plus 1 by 2. Yes, using cross multiplication method, 1 into 2 2 plus 1 into 3 3 by 3 into 2 6 by 2. Okay, 2 plus 3 5 by 6 by 2. Okay, a fraction divided by a number means the fraction into reciprocal of that number. Reciprocal of 2 is 1 by 2. Okay, 5 by 6 into 1 by 2 is equal to 5 into 1 5 and 6 into 2 is equal to 12. So this point B is 5 by 12. Okay, so the point B is 5 by 12. So we get this point B as 5 by 12. Okay, then now you can find out A. What is A? A is actually the midpoint of this 1 by 3 and 5 by 12. Right? A is the midpoint because the distance from 1 by 3 to A and A to B are equal. Right? These divisions are equal. So the distance between these two and these two are equal. So A is the midpoint of 1 by 3 and 5 by 12. Okay, that is equal to 1 by 3 plus 5 by 12 by 2. Okay, using cross multiplication itself, that is 1 into 12 12 plus 3 into 5 15 by 3 into 12 36 by 2. Okay, that is equal to 12 plus 15 is equal to 27 by 36, and dividing by a number means multiplying with its reciprocal. So that is equal to 27 divided by 36 into 2 is equal to 72. Okay, and this 27 is actually 9 into 3 and this 72 is equal to 9 into 8. So 9 and 9 get cancelled. So 3 by 8. So this point A is 3 by 8. Okay. Similarly, we can see that the point C is the midpoint of 5 by 12 and 1 by 2. Okay. Now we are going to find out the point C. Okay. C is the midpoint of 5 by 12 and 1 by 2. So C is equal to midpoint of 5 by 12 and 1 by 2. Okay. That is equal to 5 by 12 plus 1 by 2 divided by 2. That is equal to 5 into 10 plus 12 into 1 12 by 12 into 2 24 divided by 2. That is equal to 22 by 24 into 1 by 2. Okay, we can cut using cutting method. We can cut this 22 with this 2. Right? 2 is 11 times in 22. So we have 11 by 24. So our third point is 11 by 24. Okay children, I hope all of you clear this answer. Now we are coming to the last section of this chapter, that is Algebra Zero. What is the distance between the point 0 and the 3? Yes, we know that the distance between the point 0 and the 3 is the number 3 itself, right? And what about the distance between the number -2 and 0? We know the distance between the point 0 and -2 is not -2, right? This is not -2, but here the distance is the number itself. But here the one number is negative number. But the distance is not that -2. We take the negative of that -2. Right? Negative of -2 is +2. So the distance is always positive. Whatever the distance, we take the distance as positive. So that is called the absolute value of a number. Okay, distance is always an absolute value. That is, absolute value is represented like this. That is mod 3. Okay, this is mod. Mod 3 is 3. Okay, then mod -2 is also equal to 2 itself. It is not a -2. Okay, mod 3 is 3 and mod -2 is equal to 2. Okay, that means modulus or absolute value of a number means without sign the number. That is the absolute value of that number. Okay, here we have a definition of absolute value. What is that absolute value? We can check. See, if x is a number, mod x is the absolute value of x. Okay, absolute value of x. Absolute value of x is equal to x. Okay, absolute value of x is equal to x if x is positive. Okay, if x is a positive number, we know that the absolute value is x itself. Okay, that is 3 is a positive number. Then modulus of 3 is equal to 3 itself. Okay, so modulus absolute value of a number x is equal to x if x is positive. Okay, and absolute value of x is equal to negative of x if x is negative. Okay, if x is a negative number, x is a negative number, then absolute value of x is negative of x. For example, we need to find out the absolute value of -2. Okay, absolute value of -2. This -2 is a negative number. Okay, then absolute value of this -2 is negative of x. What is x here? X is -2. Then negative of x is negative of -2. That is equal to +2. So modulus of x is equal to -x if x is negative. Also, if x is a negative number, then modulus of x is equal to -x. Absolute value of x is equal to -x. That is, if x is positive, we know that absolute value of x is x, and if x is negative, absolute value of x is equal to -x. positive, negative, two cases we discussed. Then one more case is the positive, negative, then which is the other number? Yes, 0. And modulus of x is equal to 0. When if x is equal to 0. Okay, so this is the definition of absolute value of a number. That is absolute value of the number x is equal to x if x is positive. Absolute value of x is equal to negative x if x is negative. And absolute value of x is equal to 0 only when x is 0. Okay, so on the number line, the distance between the point denoted by 0 and the point denoted by another number is the absolute value of that number. Okay, distance between any 2 points, not any 2 point, distance between 0 and any point is the absolute value of that number. Okay, 0യും ഒരു നമ്പറും തമ്മിലുള്ള ഡിസ്റ്റൻസ് എന്ന് പറയുന്നത് ആ നമ്പറിന്റെ അബ്സല്യൂട്ട് വാല്യൂ ആയിരിക്കും. Okay. Now we are discussing about the distance between any 2 points on the number line. Okay, we already discussed what is the distance between any 2 points on the number line. That is larger minus smaller. Okay, larger minus smaller is the distance between any 2 points on the number line. So here we are going to check the algebra of that. Okay, that is distance between the points x and y on the number line. Okay, 2 points x and y, we are going to find out the distance between the points x and y. Okay, so we know that x and y are 2 points on the number line. Okay, then the distance between the points x and y, if x is greater than y. Okay, distance between the points x and y if x is greater than y. That is 4 is greater than 3. Then the distance between 4 and 3 is equal to 1. Right? So if x is greater than y, then the distance is, yes, distance is equal to x minus y. Okay, if x is greater than y, then distance is x minus y. Then what about if x is less than y? Okay, if x is less than y, that is 3 is less than 4. Right? 3 is less than 4. Then what about the distance between 3 and 4? The distance between 3 and 4 is, yes, we know that 1 itself is the distance between 3 and 4. So if x is less than y, then the distance is equal to, yes, y minus x. Okay, so whichever is the biggest one, so subtract the smaller one from that. Okay, we can say that the distance between the points x and y, the distance between the points x and y is equal to modulus of x minus y. Okay, the distance between the points x and y is equal to modulus of x minus y. That is, the distance between 2 points on the number line is the absolute value of the difference of the numbers denoting these points. Okay, absolute value of the difference is the distance between the point x minus y. Okay, that is the distance between the points 2 and negative 1. Okay, distance between the point 2 and negative 1 is equal to modulus of 2 minus minus 1. That is equal to 2 minus minus 1 is equal to 3. What is mod 3? Mod 3 is equal to 3 itself. Okay. Now we are going to do some problems based on this idea. This is the first question. What are the numbers x for which modulus of x minus 1 is equal to 3? Okay, mod x minus 1 is equal to 3. And which are the x's satisfy this condition? Yes, we know that modulus of x minus 1 is x minus 1. Okay, modulus of x minus 1 is x minus 1 if x minus 1 is greater than 0. That is x minus 1 is positive. Then modulus of x minus 1 is x minus 1 itself. Right? So, modulus of x minus 1 is equal to x minus 1 if x minus 1 is greater than 0. Okay. So, if x minus 1 is greater than 0, then x minus 1 is equal to modulus of x minus 1 is equal to 3. This is our condition. So, x minus 1 is equal to 3. X minus 1 is equal to 3, then x is equal to 3 plus 1 is equal to 4. Okay, 1x is this. That is, if we substitute x is equal to 4 here, 4 minus 1 is equal to, yes, 4 modulus of 4 minus 1 is equal to mod 3. Mod 3 is equal to 3. Okay, mod 3 is equal to 3. And modulus of x minus 1 is minus of x minus 1. When? If x minus 1 is less than 0. Okay, x minus 1 is less than 0 or x minus 1 is a negative number, then modulus of x minus 1 is equal to minus of x minus 1. Okay, so modulus of x minus 1 is equal to minus of x minus 1. What is minus of x minus 1? This minus is common to all the numbers inside the bracket. So minus of x is minus x and minus of minus 1 is equal to plus 1. Minus x plus 1 is equal to 3. Okay, minus x plus 1 is equal to 3. That is, if this x minus 1 is a negative number, x minus 1 is a negative number, then modulus of x minus 1 is equal to minus of x minus 1. That is, minus x plus 1 is equal to 3. And if we move this 1 to the other side, we have minus x is equal to 3 minus 1. That is equal to 2. Okay, minus x is equal to 2. Then x is equal to, yes, minus x is 2, then x is equal to negative 2. Okay, we can check. What is modulus of x minus 1 if x is negative 2? That is minus 2 minus 1. What is minus 2 minus 1? Minus 2 minus 1 is minus 3. So, mod negative 3 is equal to 3 itself. Okay. So, if x minus 1 is greater than 0, then mod x minus 1 is equal to x minus 1. X minus 1 is less than 0, then mod x minus 1 is equal to minus of x minus 1. Then we get two values for x. One is, yes, x is equal to 4 and other is x is equal to negative 2. In both the cases, we have modulus of x minus 1 is equal to, modulus of x minus 1 is equal to 3. Okay. Our next question is, prove that mod of x square is equal to x square for any x. Okay, for any x. If x is greater than 0, if x is greater than 0, what is mod x? If x is greater than 0, we know that mod x is equal to x itself. X is a positive number anengil, absolute value of x is equal to that number itself. Okay, so mod x is equal to x. Then what about mod x the whole square? Mod x the whole square is equal to x square. Okay, if x is greater than 0, mod x is equal to x and mod of x square is equal to x square. Then if x is less than 0, if x is less than 0, what is modulus of x? Yes, modulus of x is equal to minus x. Okay, modulus of, if modulus of a negative number is negative of that negative number, that is equal to minus x. Then what is mod x whole square? That is equal to minus x whole square. Negative square is equal to x square itself. Okay, so mod x, if x is less than 0, then also mod x whole square is equal to x square. So we have if x is greater than 0 and less than 0, one more condition, if x is equal to 0. Okay, if x is equal to 0, then mod x is equal to 0. Then 0 square is equal to 0, that is which is equal to x square. That is, if x is equal to 0, then also mod x whole square is equal to x square. Okay, 0 square, in both the cases 0 is the answer. So children, this much only for today. In the next class, we will discuss the last exercise of this chapter. Okay children, thank you.